Today's lesson is on density and solving density problems. We first need to know these two terms, so please write them down. Mass is the amount of matter an object contains. This is different from weight. Weight is mass plus gravity. That's something that you'll learn about in physics. Volume is the amount of space a substance occupies. And I think in geometry, you either will or you have spent some time looking at how to calculate volumes of different shaped objects. If you have like a regular solid like a cube, we could just go ahead and measure the length times the width times the height. So if we have a 1 centimeter by 1 centimeter by 1 centimeter cubed, the volume in that is 1 centimeter. However, a lot of times in chemistry we have irregular solids, and we did this in class. So we're going to do that by measuring it through water displacement. Just as a reminder, if we look at this graduated cylinder, we read from the bottom of the meniscus, and this graduated cylinder is marked every milliliter, so we estimate that next decimal place. So it is definitely 27, and then we estimate it to be 0.5. Just a little review on reading a meniscus. If we're looking at reading the bottom of that meniscus, we want to make sure if we're reading it too low, our line of sight is too high. If we're reading it too high, our line of sight is too low. And so we want to look at it, reading it correctly. We want to use that proper line of sight. We also don't want to pick the graduated cylinder up because we could tilt it. We want to keep it flat on a table. If we're using water displacement, if we measure the initial volume, so here the initial volume is 4. Notice that this is marked every 4.1, 4.2, 4.3. So we know that this is exactly 4.0, and then we're estimating that last digit to be 4.00. So the two numbers after the decimal are appropriate. And to keep it simple, when we put our two objects in that are irregular, they are 6.00, and we subtract to get the difference and find exactly. Notice that continuation of those significant figures and how we've measured it. We have to measure as good as our tool is. Density is the ratio of the mass of an object to its volume. Notice box A and box B are the same size. Box A has more of whatever those particles in it. Box B has less, which means box A has more mass for the same volume. So a higher mass for the same volume would mean that box A has a higher density. And this is a good pictorial way for you to see how that goes. More particles there. And if we're going to do some problems, what is the density of an object with a mass of 60 grams and a volume of 2 centimeters cubed? A lot of times we read volume as either centimeters cubed or milliliters. Those are our two most common ones. Our equation is density is mass divided by volume. So density, we'll take our mass of 60 grams. We'll take our volume of 2 centimeters cubed. We'll go ahead and divide. Density is equal to 30 grams per centimeters cubed. Notice that when I divide, I go with the least number of significant figures. They both happen to have 1. 60 has 1, 2 has 1, and my answer, in fact, has 1. An object has a volume of 825 centimeters cubed and a density of 13.60 grams per centimeters cubed. Find its mass. In this case, we're going to solve mass is equal to density times volume. 13.60 grams per centimeter cubed is my density, and 825.0 centimeters cubed is my volume. I'm going to multiply those two numbers, and I'm going to get 11,220 grams to find the mass. 4 significant figures in each of my part of my question, which means I have 4 significant figures in my answer. Sometimes we have to use a table to find data. The volume of an aluminum sample is 251 centimeters cubed. What is the mass of the sample? So we just are given the volume, but density for many elements is a known function, so we can look it up. It's telling us the density of aluminum on table S, which is just a table. We don't use table S specifically, but if we were to look at a table like this, for many elements, we're given the symbol, the name, some other information that we'll learn about, ionization energy and melting points, electronegativities, but you can see the column there where density is, and it gives us the density of what aluminum is, and that's where that 2.70 grams per centimeter cubed. If I know the volume and I know the density, Now I can do mass is equal to density times volume again. I'm going to take my density, I have my volume, that density came off the table, and my answer is 678 grams.